Students, welcome once again to the session. And in the last session, we were discussing about matrices. And in this direction, what we did actually, we have seen that how two matrices are added, means addition of matrices, and then how two matrices are subtracted. So addition and subtraction both runs on the similar lines in case of matrices as we did in case of numbers. Then a third operation we also discussed, that is whenever a matrix is multiplied by a number. Such a process or such an operation is known as scalar multiplication. So after having discussion on these three operations, addition, subtraction, and then scalar multiplication, so naturally the next stage is what? How or what will happen if two matrices are multiplied, or whether two matrices can be multiplied or not. So this we will discuss in this session, right? So we will start our topic with multiplication of matrices. Let us consider the two matrices A and B, where A is given like this: A1, A2, A3, A4, and B is taken as B1, B2, B3, B4, B5, B6. I have taken any two arbitrary matrices. You can take any two matrices of your own choice, but the process of multiplication or the operation of multiplication will remain valid in all cases, right? So what is our objective? We are interested to multiply these two matrices A and B. It means we want to find out the product AB. So the product of A and B simply denoted by AB as usual by the numbers, and then this AB is obtained by like this. Now see this matrix. So how this matrix is being obtained, let us discuss this condition. See, what is the process or what is the operation of multiplication of two matrices? Two matrices are multiplied on the principle: number one, rows of the first matrix should be multiplied with the columns of the second matrix, right? The operation used in process of multiplication of two matrices is this. This is your first matrix, so rows of the matrix first should be multiplied with the columns of the matrix second, right? Clear? Take the first row of the first matrix, multiply it with the first column, then second column, then third column, and then fourth column, and then so on. Then take the row 2 of the first matrix and then multiply it with the first column, then second column, and then the third column, and then so on. So doing this way, the rows of the first matrix is multiplied with the columns of the second matrix. We can get the product of the matrices A and B, which is denoted by AB, right? See this, the row of the first matrix is this. Let us take this is the first case. This is A1, this is A2, sorry, this is A2, this is A3, and this is A4. This is matrix A, and our matrix B is B1, B2, and B3. This is say B4, B5, and B6, right? This is A, this is B. What we want to calculate, we are interested to get the product of these two matrices A and B, which is simply denoted by AB. So what we will do, take the first row of the first matrix, this one, right? Multiply this row with the first column of the second matrix. What I show you, rows of the first should be multiplied with the column of the second, right? So see, A1 should be multiplied with B1. So what we will get, A1 B1 plus this A2 should be multiplied with A4. So what we will get, A2 B4. This is the product of the first row of the first matrix with the first column of the second matrix, and this product will give you the first element of the product AB. Clear? First row of the first matrix is multiplied with the first column of the second matrix. The resultant will give you the first element of the product AB. So this is your first product or the first element of the product AB. Now, then the first row will remain as it is. Now again take the first row, multiply the first row with the second column to get the second element of the product AB. See, A1 B2 A1 B2 plus A2 B5 A2 B5. This is second element of the product AB. Now the first row will remain as it is. Take the third column. This is your third column. So A1 B3 A1 B3 plus A2 B6, right? So this is the third element of the product AB. So this is how we can get the first row of the resultant, that is the product AB, right? Now we will use the same process for the second row of the matrix 1. So take the second row, this, and again multiply the second row with the first matrix, first column of the second matrix. So A3 B1 plus A4 B4, right? So this is the first element of the second row of the product AB. Now first row will remain as it is. Multiply this row with the second column, that is B2 and B5. So A3 B2 plus A4 B5, right? This is the second element of the second row. Now the second row should be multiplied with the third column, A3 B3 plus A4 B6, right? So look at this. This is the last element of the second column. So this is how we can find out this matrix as a product AB whenever the two matrices A and B are multiplied. Hope you understand the concept. Let me repeat it again for your clear understanding. Whenever you want to multiply two matrices, the operation of product is what? Rows of the first matrix should be multiplied with the columns of the second matrix. This is the basic principle. Take the first row of the first matrix, multiply the first row of the first matrix with all the columns of the second matrix. You will get the first row of the product AB. Then take the second row of the first matrix and multiply it with all the columns of the second matrix. You will get the second row of the product AB, right? So what we will do, as I have mentioned in the very beginning, rows must be multiplied with the columns. So take the rows of the first matrix and multiply with all the columns of the second matrix to get the resultant product that is being denoted by AB, right? So what we observe from this question, thus we observe that the product of two matrices is defined. Actually, what is the basic requirement or what is the basic prerequisite condition under which two matrices can be multiplied? That is, see, it is highlighted if the number of columns of the pre-multiplier are equals to the number of rows of the second multiplier. What does it mean? If you are multiplying two matrices, say A and B, so this A is called pre-multiplier and this B is called post-multiplier. Right? Pre means which is written before, post means which is written later. So A is called pre-multiplier or the first matrix, B is called the post-multiplier or the second matrix. So the product of AB is possible if number of columns of the first matrix should be equals to number of rows of the second matrix. If this condition is satisfied, only then we can multiply the product AB. But this condition is only for AB. Be careful, we are using the word pre-multiplier and post-multiplier. If you are finding AB, then A is considered as pre-multiplier, B is considered as post-multiplier. When you will find out BA, now B here is considered as pre-multiplier and A here is considered as post-multiplier. So the requirement is what? Pre-multiplier and post-multiplier. I have also told you pre-multiplier means a matrix which is written first, and post-multiplier means a matrix which is written later at the second position, right? You can also understand it by this. So we should check the requirement whenever we are multiplying any two matrices. The matrix which is written first, its columns should be exactly equal to the rows of the matrix which is written at second position. Clear? So if pre-multiplier is of order m by n, for example, you want to find out the product AB and the order of A is m by n, right? And order of B should be what? If you want to calculate AB, if A is of order m by n, then A contains m rows and n columns, then the condition is what? B must contain n rows and it may contain any number of columns, right? Say P. So what is the requirement? Requirement is this. These two terms should be same. Number of columns of the first matrix should be equals to number of rows of the second matrix. Only then the product is possible. If this condition is not satisfied, this is not possible. See, when you will multiply the product A and B and you are interested to find out AB, then what will be the order of AB? See, the product is feasible when columns of A should be equals to rows of B, when this condition is, for example, satisfied. So naturally you can find out the product AB, and when AB is obtained, then what about the order of the product? So the order of the product will be what? M by P, right? It will contain M rows and P columns. You can understand this concept by diagram. Say this A is a matrix of order m by n. It means A contains m rows and n columns. B is any other matrix of order n by p. B contains n rows and p columns. So see here, A contains n columns. So this is the column and this is the row, right? They must be equal, right? Columns of the second matrix should be equals to rows. Columns of the first matrix should be equals to rows of the second matrix. And what is this? This is the resultant order of the product AB. The order of AB will be m by p as explained here. Hope you will understand the concept of multiplication. So what we did actually before moving to the next slide, it's a very simple process. At the crux of this slide is what? You can multiply only two matrices if number of columns of the first matrix should always equals to number of rows of the second matrix. If this condition is satisfied, only then you can talk about the product. If this condition is not satisfied, you cannot multiply the two matrices. Once this condition is satisfied, then how they are being multiplied, that I have already explained. Rows of the first matrix should multiply with the columns of the second matrix, right? Let us discuss few remarks which are very important. Two matrices A and B are said to be conformal for the product AB. Conformal means their product will exist. They can be multiplied. This is the meaning of conformal. So two matrices A and B are said to be conformal for the product AB if, see this, number of columns of A, this is the condition. Number of columns of A are equals to number of rows of B, right? This is a very basic condition. If this condition is not satisfied, you cannot multiply the two matrices. Remark 2 says, if A and B are square matrices, look at very carefully, A and B are square matrices of the same order, then both the product AB and BA are defined and each is a square matrix of order n, right? The condition for multiplication of the product of two matrices, that is what? Columns of the first matrix should be equals to rows of the second matrix. This condition must be examined if A and B, if you are multiplying A and B, they are rectangular matrices. Are you getting the point? The prerequisite condition for multiplication of two matrices, that is columns of the first matrix should be equals to rows of the second matrix. This must be checked if both the matrices are rectangular. But if matrices A and B are square matrices already satisfy this condition, then you have nothing to check. If A and B are matrices of order 2 by 2, then you can always find out the product AB. If A and B are matrices of order 3 by 3, then you can always find out the product AB, not product AB, even BA. So what this remark 2 actually refers, if A and B are square matrices of the same order n, order of A is n, order of B is n, then we can always find out the product AB as well as BA both, and the order of the product AB as well as BA will be also n. That is same what the orders of A and B are. Remark 3 is what? If A and B are two rectangular matrices, look at here, we are using the word rectangular, and in remark 2 we have used the word square. This is the difference, right? If A and B are any two rectangular matrices such that the product AB exists, see, product AB will exist when columns of A must be equals to rows of B. Only then you can multiply AB, because A and B are rectangular matrices. So if A and B are two rectangular matrices such that the product AB exists and their product BA may not exist, right? See, AB means what? If order of A is say m by n and order of B is n by p, right? This condition is satisfied. Then AB is defined. But if AB is defined, it never means or it never implies that BA is also defined, because in case of BA, what is the requirement now? Columns of B should equals to rows of A. They may equal, they may not be equal. So what does it mean? It simply refers the remark 3, that is A and B are any two rectangular matrices, then AB may possible, number 1, AB may not possible, number 2. AB may possible, but BA may not possible, number 3. AB may possible, BA may possible, their orders may be different, right? Are you getting all these points? So I will discuss all these possibilities in the subsequent slides. So first take this case, if A and B are two rectangular matrices such that the product AB exists, then their product BA may or may not exist. And let us understand this remark by this example. Say this A is a matrix of order 3 by 2. It contains 3 rows and 2 columns. And this B is a matrix of order 2 by 1. It contains 2 rows and 1 column. We are interested to find out, say, AB, right? So AB is possible when the columns of A must be equals to rows of B. Now check this condition. A contains 2 columns and B contains 2 rows. So this condition, look at here, is satisfied. A contains 2 columns and B contains 2 rows. So we can find out the product, and this is what product is written here. A is this, see, 2 into 3, this is the first row, multiply this, the first column. 2 into 5 plus 3 into 1. 2 into 5 plus 3 into 1. Then take the second row. 4 into 5 plus 1 into 1. 4 into 5 plus 1 into 1. Then take the third row, 7 into 5 plus 5 into 1, 7 into 5 plus 5 into 1. Simplify it. You will get 13, 21 and 40 as a product AB. So if 2 is there, 2 is there, this condition is what? This is the condition for the product AB. What is the order of the product? The order of the product is what? Say here, A is a matrix of order 3 by 2 and B is a matrix of order 2 by 1. So this is the condition for the product, right? And this is the condition for the order of the resultant AB. So the product AB will have, it will contain 3 rows and 1 column, right? As I have already explained. So AB is there, but what about BA? See, BA means what? What does it mean? The columns of B should be equals to rows of A. Now the situation has been just reversed. BA means the columns of B must be equals to rows of B. How many columns B will have? Order of B is what? 2 by 1. And order of A is what? 3 by 2. Here B contains 1 column and A contains 3 rows. 1 is not equals to 3. Therefore, BA, the product BA is not possible. Clear? Are you getting the point? There are many situations we will encounter further in the subsequent texts in the incoming slides about the product of 2 matrices. So whenever you are multiplying two matrices AB to find out their product, you must check the condition of the product. Then proceed without checking the condition. But if the matrices are square, then you have nothing to check because they already satisfy the condition. However, if the matrices are rectangular, then you will have to check the requirement for the product of the 2 matrices before finding out their product. Let us take this example to understand the concept very easily. Let A is equals to this matrix. This is the matrix A and this is the matrix B. Find AB and BA. Is AB is equals to BA? Right? Is the product AB is equals to BA? See, A is A. What is A? I have told you just A is a square matrix, right? Of order 2 by 2. B is also a square matrix. Its order 2 by 2, its order also 2 by 2. So both are square matrices. AB is always possible. We have nothing to check. BA is always possible. We have nothing to check. What we have to check? This is true or not. AB is equals to BA or not. This is the only what we want to check or test. Whenever 2 matrices are square and they are of the same order, you can always find out their product AB as well as BA. Now you can find out the product AB. Since A and B both are square matrices of order 2 by 2, hence AB and BA both exist. We can find out the product AB as well as BA. Now you can find it. See, AB, this is the matrix A and this is the matrix B. Use the same operation of multiplication of 2 matrices. That is what? The rows of the first matrix should be multiplied with the columns of the second matrix. So take here, the row is this is the first row and this is your first column, right? 1 into 1 plus minus 1 into 4. 1 into 1 plus minus 1 into 4. We are getting this, right? Now multiply the first row with the second column. Second column is this 1 into 1 minus 1 into minus 1. So 1 into 1 plus minus 1 into minus 1. You are getting this, right? The operation of the first row with all the columns of the second matrix are now over, right? First, perform the operations of the first row with all the columns of the second matrix. Then repeat the same operation for the second row of the first matrix. Now, we will take the second row, right? Second row is what? 2 and minus 1. Now, we will take this row. Multiply this row with the first column. This is our first column. 2 into 1 plus minus 1 into 4. So, 2 into 1 plus minus 1 into 4, right? The first row should be multiplied with the second column. 2 into 1 plus minus 1 into minus 1. So 2 into 1 plus minus 1 into minus 1. Clear? Are you getting the operation? Now simplify it. After simplification you will get this, and finally minus 3, 2, minus 2, 3 is the product of the two matrices A, B. Right? So this is how we can find out the product of any matrix. Likewise, we can also find out the product AB. See, this is B, this is A, right? So multiply the same product, but the order is being reversed by using the same process. This is the first row. Let us take again, and this is your first column. 1 into 1 plus 1 into 2. 1 into 1 plus 1 into 2, right? First row with the second column, 1 into minus 1 plus 1 into minus 1. So 1 into minus 1 plus 1 into minus 1, second element. Now come to the second row. Multiply with the first column. 4 into 1 plus minus 1 into 2. So 4 into 1 plus minus 1 into 2. Now the second row with the second column. 4 into minus 1 plus minus 1 into minus 1. So 4 into minus 1 plus minus 1 into minus 1. Clear? Now again simplify it. After simplification you will get this, and this is equals to what? Oh sorry, this is equals to this, right? 3 minus 2, 2 and minus 3. This is the required matrix. Here 3 minus 3 2 minus 2 3, here 3 minus 2 2 minus 3. So from these two examples we observe that AB is not equals to BA, right? Clear? Now we will discuss some properties, because look at here, properties are very important. Addition, we discuss some properties of addition. Then we discuss scalar multiplication, and we discuss some properties of the scalar multiplication. Now we are doing multiplication of matrices, so we will suddenly discuss few properties of the matrix multiplication, because these properties are very helpful sometimes to finding out the solutions of the various questions in a simpler way, right? Look at the property 1. Matrix multiplication is not commutative in general. If you recall, when we discussed the properties of the matrices under addition, the first property was what? The matrix addition is always commutative. That is, if we take any two matrices A and B, we find out the product of A and B are the product of B and A, they both are equal. This was the property of what? Commutativity under addition. If A is added to B or B is added to A, in both way you will get the same matrices, right? But here in case of multiplication, if this addition is being removed by multiplication, means A into B, this B into A. This is not true. Means whenever we have two matrices A and B, AB need not be equals to BA, and this is known as commutative property. And matrix multiplication is not commutative in general. See this from this example. If A and B are two matrices, then AB is not equals to BA. AB is not equals to BA simply means it's not true always, right? Sometimes it may true and sometimes it may not true. But in case of addition, This property is true always. That is why we call it as matrix addition is commutative. But this is not true always. So we will say that the matrix multiplication is not commutative. Let us understand this property by this example. This is A and this is B. This is a square matrix, but this is a rectangular matrix. So to find out the product AB, we first check the condition. Order of A is 2 by 2 and order of B is 2 by 3. So this is the requirement for the product satisfied. And this will be the order of the product. The matrix AB will be of order 2 by 3. So multiply this AB, 2 into 3 plus 1 into 2, that is this 8, right? After multiplication, I have explained this product process many times. Now the product AB is this. Finally, you are getting this matrix. Its order is 2 by 3 from here. But BA is not defined because BA means columns of B should be equals to rows of A. The order of B is 2 by 3 and order of A is 2 by 2. B contains 3 columns, A contains 2 rows. So this condition is not satisfied. Therefore, BA is not possible because B is a 2 by 3 matrix and A is a 2 by 2 matrix. What is the requirement for the product of the two matrices is not satisfied, so we cannot find out BA, right? For example, if A is this and B is this, then AB is this. This is a rectangular matrix. See, order of A is 2 by 3. Always check the condition. Order of B is 3 by 2, right? So this requirement is satisfied. The order of the product will be 2 by 2. So we are getting this 2 by 2 as a matrix. And what about BA? B contains 3 rows and 2 columns. A contains 2 rows and 3 columns. So B contains 2 columns. B contains 3 rows. B contains 3 rows and 2 columns, and A contains 2 rows and 3 columns. So BA, this condition is satisfied. So AB is possible and BA is also possible. Hence, AB and BA both are defined, while AB is of order 2 by 2 and BA is of order 3 by 3 matrix, and AB is not equals to BA. So what we observe from these two examples, if A and B are any two matrices, the product is possible, you know the condition. In some cases, AB may possible, BA may not be possible, right? As we have seen in this example as well as last example. AB is possible, BA is possible, as we have seen from this example. See here in this example, AB is possible and BA both are possible. But the order of AB is 2 by 2 and order of BA is 3 by 3. What does it mean? The product of the two matrices AB as well as BA both are possible, but their orders are not same. So naturally, if their orders are not same, how they can be equal? So what is this? What does it mean actually? It simply means the product of two matrices is only defined if the rows of the first matrix is always equals to columns of the second matrix. So students, with this I think I should stop it here and I will continue in the next lecture. Okay. Thank you very much.